Hi everyone, this is Amy from the Helms Academy, and today we're doing our Math Roundtable recap from January 28th, 2021, and we'll be looking at problems that use images. So to start with word problem 1, it says the given 3-unit by 12-unit rectangle in the standard XY coordinate plane was obtained by applying a sequence of transformations to the 1-unit by 4-unit rectangle. One of the transformations was a dilation centered at the origin. Okay, so starting with that information, we have a lot to talk about. So first of all, look at the image. Do you see the 3-unit by 12-unit rectangle on the right side? So we're starting with that, and it says, what about that? Well, they said first, we know it's sitting on an XY coordinate plane. So think about if you are graphing something, putting numbers on a graph, you always have your x-axis and your y-axis. And we can see those labeled there. So we know that these two rectangles are on this coordinate plane. Okay, so with those pieces, now we know that that larger rectangle was obtained. So we got to it by doing what? By applying a sequence of transformations. Well, transformations meaning changes. So we made some changes to the 1-unit by 4-unit rectangle. Okay. One of the transformations was a dilation centered at the origin. So the dilation, think about when your eyes are dilated, that means that the pupils get bigger. So dilation means it was made larger here. All right, so I want to first look at my two rectangles and see if there's anything they have in common. So right away, I see one is 1 by 4, and the other one is 3 by 12. So that's an interesting thing. I want to see, do those numbers have anything that is maybe similar about them? Right away, I think about how 1 times 3 is 3 and 4 times 3 is 12. I also notice that they look similar in their shape, just that one is a little smaller than the other. So it looks like not a lot changed about them in proportion-wise, just that they were blown up, made larger, or dilated. So when we look at our answers here, it says, which of the following sequences could have been applied? Now, you'll notice that all of our options start with dilation of a scale factor of. Now, dilation we know means get bigger. And when you see those words scale factor, I want you to think multiplication. So let's think about that. Dilation with a scale factor of 3 or multiplied by 3. Dilation with a scale factor of 12 or multiplied by 12. Now, which one did we say was true? Well, we had already noticed earlier that 1 times 3 is 3 and that 4 times 3 is 12. So that tells me that we can already get rid of the ones that say 12 here because we're not multiplying by 12. We do get 12 in one of them, but we're multiplying by 3. So it's a scale factor of 3. Now, look at the 3 options that we have remaining. One of them says centered at the origin, followed by a rotation about the origin. Now, what's our key word here? Well, the word that stands out to me is rotation. So look at our smaller rectangle and look at our larger rectangle. Does it look like we at any point rotated that smaller rectangle to get the larger one? No, they're kind of sitting the same way. So rotation, not going to be a good option. Let's look at C. It says, centered at the origin, followed by a reflection across the y-axis. So think about a reflection, right? The y-axis is our center point. So that means that if something is this far away on this side, it needs to be the same distance on the other side. In this case, our smaller rectangle is flush up against that y-axis. So if we have a reflection here, that means that our other rectangle has to be flush up against the other side of the y-axis. Is that true? Not here. So reflection, we're going to cross that one off. So let's look at letter E. It says dilation with a scale factor of 3 centered at the origin, followed by a translation of 16 units to the right. Well, I want you to take a look here now at our XY, our graph that we're looking at. So at the middle, we see that number 0. So it's the center point of the graph. So if we see 0 there, and that's where the edge of our smaller rectangle hits, then we want to look at where that right edge of the larger rectangle hits to see how far it was moved over, because we can definitely see that it was moved over to the right. So if we start at 0, we see that we get up to 4 on the bottom, and then we don't have any more numbers across that line. So I wonder if we can use other information. And when I look up at the top of the rectangle, I see that that's 12 units long. So if I add that together, my 12 units that are across there, with the 4 that provide that gap in between the two rectangles, that's 16. That means the outer right edge of this rectangle is at 16 on the line, and the other one was at 0. So that's a 16 unit difference, and it was moved to the right. So with that information, when we put all that together, our best option here is going to be E. Let's take a look at word problem 2. It says the following square and rectangle with side lengths in inches have a combined area of 56 square inches. Which of the following equations, when solved, gives the side length S inches of the square? So if we take a look at what we have, we see S on top of the square. So that's the length of one side, but we know all 4 sides are the same length. And for a rectangle, we have 2 sides that are the same length and the other 2 sides that are the same length, but they're different from one another. So we see the one side is just an S, and the other side is S plus 6. Now, how do we get area of something? Well, we do S times S, side times a side. Now, in this case, for the square, we would need to, they're all the same side, so we could just do S squared. Done. Now, I already know part of my equation then is going to be S squared. So when I look at my options and I see 2 that don't have S squared on them, I'm going to cross those off. So now we've already narrowed it down to 3. Now, my rectangle, I'm going to need to multiply the length and width. So I'm going to need to multiply S and S plus 6. Now, when I look at my options, I see 2 of them that include that, S times S plus 6, but 1 that does not. So now I've narrowed it down to 2 options. Now, remember, we're thinking that this altogether equals 56, but the problems that we have here, the answers that they show only equal 0. So think about it like this. If we know that S squared plus S times S plus 6 equals positive 56, how do we get rid of that 56 on the other side of the equal sign and bring it back onto the side of the equal sign that we're working on right now? Well, if we had a positive 56 as our answer, we want to do minus 56 on both sides. So that means that our positive 56 would go to 0, equals 0, and that we would ultimately have a minus 56 with our S squared plus S times S plus 6. Let's look at word problem 3. It says, workers poured concrete for a driveway in the shape of a right rectangular prism with dimensions of 40 feet by 12 feet by 6 inches, as illustrated. To the nearest cubic yard, what was the total amount of concrete the workers poured? So I know from looking at this that we need to figure out how much volume is here because we need to fill that 3-dimensional area with concrete. Now, one problem I run into right away is that these are not all in the same units. So we have feet and we have inches. So I'm going to convert my 6 inches to think about it as half a foot. So if I wanted to find how much concrete this area could hold, I would multiply 40 times 12 times 0.5, or half. When I put all of those together, I get 240 cubic feet. So when I look at that, I say that might be the right answer because we see that on E. But I need to pay attention to that the answer is asking for cubic yards. So how many feet are in a yard? Well, 3. Now remember, when you're trying to convert something from a smaller measurement to a larger measurement, like a foot to a yard, then we actually need to divide, not multiply. Because for every 1 yard, there are 3 feet. So if we're currently in feet, we need to condense those down to a smaller number. So if we currently have 240, we need to divide that by 3 to find out what it would be in yards. So 240 divided by 3 would be 80 cubic yards. For our last problem today, it says the amount of time Aiden spent on a rowing machine each day last week is recorded in the following table. To the nearest minute, what is the mean number of minutes per day Aiden spent on the rowing machine last week? Well, the key here is looking at what did I want us to solve for? And it says, what is the mean number? Now, if you see mean, it does not mean mean as in how someone is feeling or acting. It means the average. So to get an average, we need to add up all of the numbers of minutes from that week and divide it by the number of days, which in this case is 7. So once we get our total number of minutes, which would be 120, and we divide that by 7, we get 17 and a few decimals. But if we round that to the nearest whole number or nearest minute, then we would get C, 17. Thank you so much for solving with me today, and good luck on whatever test you might be preparing for. Whether you're working on the GED, the HiSET, or the TASC, we have tons of videos here on the Helms Academy YouTube channel to help you out, and you can subscribe to get all our latest updates. You can also check us out on Instagram and Facebook and on our website at helmsacademy.org.